Hey everyone, this video is on quadratic trigonometric equations. Um, so we're just going to dive right into it. So it says right here, solve the equation sine squared theta minus sine theta equals 2. This is quadratic because we have this squared right here, so that's what makes it a quadratic trig equation. You'll also see why it's a quadratic trig equation in a minute, because what we're going to do right here is we're actually going to do we're actually going to do a substitution. I'm not going to use U because we typically have been using U for like the angles. I'm going to use A as my substitution here. So I'm going to say let A, and you can use whatever letter you want. Like it doesn't matter at all. Equal to sine of theta. So now when I rewrite this, instead of sine squared theta, this is a squared. Instead of minus sine theta, this is minus a, and then equals 2. And now maybe it's a little bit clearer why this is quadratic. So we have to get everything together on one side, subtract the 2, and then we're going to factor and solve. So here I'm going to say a minus 2 and a plus 1, which means that a equals 2 or a equals negative 1. But remember, a is sine of theta. So here, sine of theta equals 2 or sine of theta equals negative 1. Now, a reminder that sine, just sine of theta, no transformations, no nothing, has a maximum of 1 and a minimum of negative 1. So this is too large. This is not possible. But also remember that sine of theta is just the opposite over the hypotenuse right here. And so the hypotenuse is always larger than the opposite, which means that the opposite over the hypotenuse has to always be between negative 1 and positive 1. All right, cool. So we ignore this. There's no way that I can solve this at all. And then we just figure out what this answer is right here. So I want to know where sine of theta is equal to negative 1. We can look at this two different ways. One way we can look at this is we can actually look at the circle, and we want to know where the sine of theta is equal to negative 1. When I look at the circle, remember this coordinate down here is 0, negative r. And remember, sine of theta is always going to be y over r. And here your y value is negative r over r, which is negative 1. So that means that theta here would be, this is at 270 degrees. So this right here would be at 270 degrees. But we can also look at it using the sine graph, because we know the sine graph starts at starts on the axis, excuse me. Each critical interval is 90 degrees. So here's 90 degrees. Sorry, I should write 180 right here. So then this would be 270. And at 270, the value of sine is negative 1. So those are the two reasons why we can say that theta equals 270 degrees. Okay? Okay, so in this example right here, I'm going to do the same exact starting point that we did before, where I'm going to do now my a substitution. So we're going to say a is cosine of x. So to rewrite this right here, this would be 3a squared minus 11a minus 4 equals 0. So now I would factor and solve this right here. So 3a squared would be 3a times a. Here we need to have two things that multiply together to give us 4. So I'm going to try, I know that this is going to be a larger number compared to the rest of the numbers right here. So this is going to be a 4 here and a 1 here. If I put a minus here and a plus here, this gives me 1a, this gives me negative 12a, that gives me the negative 11a that I'm looking for. So, but don't forget that a is cosine of x. So here we can now say cosine of x equals negative 1/3. And that cosine of x is equal to 4. So remember again, this is just like sine. Sine can only be between negative 1 and positive 1. Cosine can also only be between negative 1 and positive 1. So cosine of x equals 4 is impossible. So this is the only equation that we can really solve. We're going to find our related acute angle. And to find our related acute angle, we're going to do cosine of x, our related acute angle. We're going to use a positive 1/3. So then we're going to say our related acute angle is the inverse cosine of positive 1/3. And we know that positive 1/3 is not one of our special ratios. I won't get 1/3 from any of our special triangles. So I'm going to actually use the calculator here. So I'm going to do the inverse cosine of 1/3, and I figure out that my related acute angle is about 70.5 degrees. So here we can say that x sub r is equal to approximately 70.5 degrees. Now we need to actually put this on our Cartesian plane to determine what the actual angles are. And here, remember, cosine is negative, which means that we are looking at quadrants 2 and 3, where we know the related acute angle. So our answer in quadrant 2 is going to be 180 degrees minus our related acute angle. So our answer here is going to be approximately, because again, this 70.5 is also an approximation, 109.5 degrees. And then in quadrant 3, our answer for our second answer is going to be 180 plus 70.5 degrees. So our answer right here is going to be approximately 250.5 degrees. So that means that our two solutions are 109.5 and then 250.5. Okay, in this next example, this one's a little bit trickier, so pay really close attention to this right here. For starters, this question right here, we could do a substitution, but it's not really that necessary. But also please be aware that this is a single term. So I'm going to move this over to the other side. So 0 equals 2 cosecant theta minus secant theta cosecant theta, okay? And now we have two terms. And in order for me to factor, I should have said these questions in the last questions that we've solved as well, but we always go through a list of questions. And the first question we always ask ourselves is there a common factor? And when I look at this right here, I can see that there's a cosecant of theta in common with both of these. So what I'm going to do is I'm going to factor out a cosecant of theta from both of these right here. And this would end up becoming 2 minus secant of theta. Now, if you do want to do substitution, that's fine. So if I do substitution, I'm actually going to do two substitutions here. I would say either I would use A is equal to secant of theta, and then I would say that B is equal to cosecant of theta. So when I write out this equation right here, this piece right here, this would end up becoming AB, and then on this side over here, this would just be 2b. Subtract the AB from both sides, and then factor out the B, so you get 2 minus A right here. So it's the exact same idea. So what does that mean right here? This means that either cosecant of theta equals 0, or this means right here that secant of theta is equal to 2. What does this mean right here? That either B equals 0 or A equals 2. Well, A is secant of theta and B is cosecant of theta. So either way, you get the same end result. Okay, but the problem with this right now is that these answers right here are reciprocal ratios. So we need to rewrite these using the actual like primary trig ratios. So cosecant is the reciprocal of sine. So I'm going to say sine of theta, and now I'm going to do the reciprocal of this value right here, which is going to be 1 over 0. And so this right here does not work, right? This is undefined. 1 over 0 is not possible. So here, there is no solution for sine of theta at all, okay? Now for this one right here, we're going to say that the cosine of theta, because that's the reciprocal of secant, is equal to 1/2. So here, we're going to find our related acute angle, which is going to be, we'll draw this out and find our special triangle right here. So cosine is going to be 1 over 2. So we know that this is 1, this is 2, which means that our related acute angle right here has to be 60 degrees. Okay, so we know that our first answer for theta is in, cosine is positive right here. So our first answer for theta is going to be in quadrant 1, degrees. But then our second answer for cosine of theta is going to be in quadrant 4 because Cosine is positive in quadrant 4. So we're going to call this theta 2, and then to figure this out, I would do 360 minus our related acute angle, which is 60 degrees. So this is 300 degrees. So our two solutions that we've gotten so far are 60 degrees and 300 degrees. However, our answers must be between negative 360 and positive 360. So if theta 1 is 60 degrees and theta 2 is 300 degrees, remember we have to subtract an entire period from both of these answers right here. So theta 3 would be 60 minus 360, which is negative 300 degrees, which makes sense that this is negative 300 because I'm going backwards clockwise by negative 300. And then the second answer is going to be negative 60 degrees because you do 300 minus 360, or you can just see right here that you're going backwards by negative 60 degrees. So your four solutions that we get right here are negative 300 degrees, negative 60 degrees, 60 degrees, and 300 degrees. And that's it for this question and this video. Let me know if you have any questions, and I will see you in class. Bye.